Hello and welcome. My name's Andrew Howe, and today I'm going to talk about writing extensions for ModSecurity. This video is a companion piece to a written blog post over on Loadbalancer.org, which I wrote, and in this video I'll be going through the steps and instructions that are detailed over in the written blog post. I'm working on a CentOS 8 machine here. I've already got a working Apache and ModSecurity set up. I compiled Apache and ModSecurity from source, so I already have all of the prerequisite parts for writing ModSecurity extensions. If you don't already have it, then you'll need to go and grab the source code for the exact version of ModSecurity that you're currently using. But I currently already have that, so I'm going to navigate to that directory now. And the directory we're interested in is the ext directory. So this directory contains some example files of example extensions to ModSecurity. So you could take one of these examples and modify it and use it as a base for writing your own extensions. I'm going to start by creating a new file to hold my transformation extension. So I'm going to call that mod transformation scrabble.c. The first thing I'm going to do is add in all of the required file inclusion directives. And I'm just going to copy and paste those in. And you can grab those from the example transformation function if you don't have them. Let's start with the most interesting part. Let's start by writing the function that actually performs the transformation that we're interested in. All transformation functions follow the same pattern. So we're going to put that pattern in here and name our function as Scrabble. Call it Scrabble. So first we have this parameter here, which is a memory pool assigned by the Apache Portable Runtime, and we can use this to allocate memory to hold data if we need to. The input parameter is a pointer to the input string that we need to transform. The input len parameter is the length of the input string. Now it's important to note that ModSecurity doesn't use null terminated strings. Instead it uses length parameters to tell us how long, how many characters long a given string is. We have a pointer to a string here, rval. So we use this to point to the output string. So once we've transformed the input string however we need, we finish by making sure that rval points to the transformed output string. And rval len is the length of the output string. So we'll need to keep a track of the running score total for the input string that we're seeing. So we'll need a variable for that. So let's define a long integer score. And that is initialized with a value of 0, because every score needs to start at 0 and grow over time. And we'll be examining the input string one character at a time, and we'll be doing that using a while loop. So we'll need a counting variable. We'll use I, and we'll start that at 0 as well. So as mentioned, we'll use a while loop to loop through each of the characters in the input string. So we'll use a condition of while I is less than input len. So this will allow us to loop through each character one at a time and perform some arithmetic. To look up the score of each individual letter in the input string, we'll use a switch statement. And what we're going to be examining is the input string and we're interested in looking at the ith character of the input string. So that will allow us to look at each character one at a time. Now we need to set up our case labels. We could be passed either uppercase characters or lowercase characters. To make life simpler, we're just going to account for both uppercase characters and lowercase characters. So the first thing we need to do is make a note of which letters are associated with which Scrabble scores. The letters that score 1 point are A, E, I, O, U, all of the vowels, plus L, N, S, T, and R. The 2-point scoring letters are D and G. We have B, C, M, and P for 3 points, F, H, V, W, and Y for 4 points, K on its own for 5 points, J and X score 8 points, and the highest scoring characters, Q and Z, which are worth 10 points apiece. Now what I'm going to do is put together a quick vim macro, which will expand these letters into case statements for me, both lowercase and uppercase variants. Now that we have all of our case labels in place, we can add the scoring statements. So for the letters that score 1 point, we will increase the value of score by 1 and break. For the letters that score 2 points, the score will increase by 2. And the same for the 3-point scoring letters and the 4-point scoring letters, K, which scores 5 points, the 8-point scorers, and finally the 10-point scorers. One last thing we need to account for: what happens if we encounter a character which is not a letter? Well, in that case, the score shouldn't go up. We don't have a score increase. So, not a letter, no score increase. So we'll include a default case, which will do nothing, just break. And following our switch statement, as the final part of our while loop, we'll increment the counting variable I. So that's our while statement and our switch statement put together. So this will loop through the input string one character at a time. It will look up the score for each character and keep a running total so that we're left with the full combined Scrabble score of an input string. Now that we have our score, we need to return it to ModSecurity. Numeric values are returned to ModSecurity as strings. To save us the time of having to allocate a new chunk of memory to write our answer to, we can just reuse the memory that the input string has been using. So we can write our answer string straight over the top of the input string. So what we'll do is we can use the sprintf function, and we want to write our string over the existing input string, and we'll write the value of our long integer, and we'll take that from the score variable that we've been adding to over time. So if you remember when we started defining our function, we had the rval parameter. So we need to make sure that this points to the output string. So once we've finished with our transformation, we need to make sure that rval points to the string that's being transformed. So in this case, we want to point rval at the input string, because we've written our answer, our transformed string, on top of the input string. So we'll set the value of the rval pointer to be equal to the input pointer. So we're now pointing at the string that we've just written. We need to make sure that we return the length of our output string. So we'll say that the rval length variable is equal to the length of the input string. So we can just use string length to calculate the length of the input string, which now holds our answer, our transformed output string. Finally, to close out our function here, we need to return a value. With ModSecurity, a transformation function should always return either 0 or 1, and it should return 1 if the content that's being returned is not identical to the input. So with our function here, because we're taking an input string and returning a Scrabble score, so we're taking an input string and returning a numeric value in the form of a string, we're always going to be changing the input string. It's always going to be different. So we can unconditionally return a value of 1 here. So we're always going to be changing the input, so we can return 1. There's one special scenario that we need to account for. So what happens if our transformation function is given a very short input string? So if you consider the string Z, so just the single letter Z. So letter Z, as we've seen up here, a Z has a score of 10. So if we received the single letter Z as an input string, it would score a total of 10, and we would then need to write the string 1, 0 over our input string. Well, that's problematic because our input string is only 1 character long, the letter Z, but we're trying to write a 2-letter string, 1, 0 for the score, over the top of our input string. So that's a very bad idea. We shouldn't be doing that. In that scenario, what we need to do is allocate additional memory to store our answer, because the output, the transformed string, is longer than the input string. So we can't write our answer on top of the input string anymore. So let's write a little comment here explaining what this situation is to remind us in the future. And the sprintf function that we're using terminates the string that it writes with a null character. So the situation is actually a little bit worse than we thought. So with the example of the input string of a single letter Z, what's actually being written is a 1, a 0, and then a terminating null character. So we would require 3 bytes of memory to correctly write that output string. So we're going to test for this scenario in a very simple way. We're going to use an if statement. And if the input length is less than 3, so we're testing for an input string which is 1 or 2 characters long. So in that scenario, what we want to do is we're going to allocate additional memory. And we assume the worst case scenario, which is that we have a total score which is a 2-digit score. So we require 3 bytes to store our answer string. So that's a digit, and a null character. So what we do is we point the return value pointer, and we point it to the the return value of the APR palloc function, which takes the memory pool that we defined earlier for our function, and we tell it how many bytes we want to be assigned. So we want 3 bytes of memory to be assigned. And we then cast the return value of that as a pointer to a character, so a string, and we then set that value in the rval pointer here. So rval is now pointed to a block of memory 3 bytes long, so that's plenty long enough to store our score string. So we then use sprintf to again print the total score as a string. Except this time we're printing the string into the memory that we've just allocated. And again, we want to set the rval length variable to be the length of the transformed string that we're returning. So once again, we can use the string length function, and we're looking at the length of the string that rval is now pointing to, which is our answer string. And the same as before, once we've done this, we can return 1, because we've transformed the input string, and the input is always going to be different to the output. So we can return 1 unconditionally again. And now that we've accounted for this special scenario, our transformation function is complete. What we need to do now is to add some boilerplate to make our transformation function work correctly. So firstly, we need to add a registration function, which will register our new transformation function with ModSecurity. And we need to do that so that our transformation function can be used. This function can just be copied from the example transformation function in the ext folder. The important part is that we need to give our function a correct name, which we'll see in a moment. So you can see here, we've defined the name that we're going to use to refer to our function when we want to use it in a sec rule. So this is the part of the function that we need to make sure is correct, and we need to change to the name of our transformation function. There are 2 more pieces of boilerplate code that we need in order to finish off our custom transformation here. Firstly, we need to write a register hooks function, and again this can be copy-pasted from the example transformation code if needed. And finally, we need to include a special structure, a module structure, and that indicates to Apache that this is indeed a genuine, valid Apache module. And again, this could be copy-pasted from the example, and it looks like so. And you can see here that we're referencing the name of our module, which is important. So you'll need to make sure that that has a unique name for your specific transformation function. And that's it. That's our transformation function completed. And again, just make sure that you've given a name here to refer to your module. So the name of the module structure is important, and that's because this is the same name that we're going to be using later to refer to our module in the Apache configuration file. So you need to make sure that this is unique, and you'll need to refer to it later on. So now that we've finished writing our custom transformation, we can compile it as an Apache module. To do that, we're going to use a tool called the APXS tool. And if you've compiled Apache from source, you probably have this ready to go on your system already. So I'm going to use it now. And I'm going to use the switch C to instruct it to compile, and I to instruct it to install the module that it compiles. And I'm going to include the source directory for the version of ModSecurity that I'm using. And I'm also going to include the source directory for libxml2, which if you've compiled ModSecurity from source, then you should have this already installed as it's a prerequisite. And finally, I'm going to give it the file name that I want to compile. So I'm going to give it the transformation that I've just written. And I can see that I've made a typo I often make, which is I've written apt instead of APR. I'm too used to using apt-get on Debian. It's become burned into my brain. So correct that, and let's compile again, and hopefully we get no error messages this time. And there we go, that was successful. So if I navigate to my Apache installation, and if I cd into the modules directory, we should see that my new transformation function has been installed. There it is. It was installed by the -i flag of the APXS utility. So all we need to do now is load our module. So I'm going to open up my Apache configuration and add an additional load module line. So load module. And here we give the name of the module that we've just written. So this is the same as the name of the module structure that we wrote. So that was tfn Scrabble module. And let's point it to the location of the module. And it's worth mentioning as well, if you call the APXS utility with a -a flag as well, that will attempt to automatically add the load module line to your Apache config. If not, it's simple to do as we've just done it by hand. So now we're all good to go to test starting Apache. First of all, I'm going to test Apache in debug mode just to make sure that it doesn't crash. And that's looking good. So now what I'm going to do is write a simple sec rule which makes use of our new Scrabble operator, and then we can test it. So I'm going to add a simple rule here in my Apache configuration. So sec rule, let's look at the arguments collection. And I want to say I'm going to block any argument, I'm going to block any request which contains an argument with a Scrabble score greater than or equal to 20. So 20 is my Scrabble score threshold for blocking. Let's give it a rule ID of 1. I want it to take place in phase 1. I want to deny the request if the rule matches. And for my transformation pipeline, I'm going to start with the customary t_none to reset any existing transformation functions. And then I want to apply my Scrabble transformation. And I want to log the result. And I want to leave a message in the log, which is the Scrabble score that's been achieved. So Scrabble score and the matched variable. So that should be enough for us to conduct some simple tests. So I'm going to quit this, and now I'm going to start Apache for real. So Apache bin, Apache control, and we want to start. Okay. So now what I can do from my host machine here is I'm going to do some simple curl commands to test my new sec rule. So we can see that we can hit the index.html page here and get a 200 OK response. So I'm first going to test by sending a query string parameter, which is the word aardvark. And that's getting a 200 OK. And I know that the word aardvark has a Scrabble score of 16. So 16 is below our threshold of 20. So we are expecting that request to be successful. So now I'm going to test again, but I'm going to use the word xylophone, which has a Scrabble score of 24. So if our Scrabble transformation is working, this request should be blocked. And there we go, we got a 403 forbidden response. And we can take a look at the logs to just confirm that everything is working as expected. So look at the error log. There we go. We can see that we got a Scrabble score of 24. That caused our request to be denied by ModSecurity. So we can see that our new Scrabble transformation function is working as intended. I hope this has been useful. A Scrabble transformation function isn't of much practical use in the real world, but hopefully you can see how this gives us a way of adding completely custom functionality to ModSecurity in order to inspect our HTTP traffic in a meaningful way. That's all for now. Thanks for watching.